Hello there. Thanks for joining us today. I have your resume here, and I see you have recently graduated and have been diving deep into Flutter. To start things off, why don't you just tell me a bit about your journey with Flutter and what sparked your interest in the framework?
Hi, thank you so much for having me. I really appreciate the opportunity. My journey with Flutter actually started during my final year of university. I was working on a project for a local community centre, and I wanted to build something that worked on both Android and iOS without having to write the entire codebase twice. I had heard about Flutter and Dart, and the idea of a single codebase with high performance really appealed to me. Once I got into it, I fell in love with the hot reload feature. Being able to see my changes instantly made the learning curve feel much more manageable. Since then, I have spent most of my free time building a few personal projects and taking online courses to strengthen my fundamentals. I am still very much a beginner in terms of professional experience, but I am incredibly passionate about the ecosystem and eager to apply what I have learned in a real-world team setting.
That enthusiasm is great to hear. It is always a plus when someone is genuinely excited about the tech. Let us jump right into the technical side of things. Let us start with the basics. For someone who is new to the framework, could you explain the concept of a widget in Flutter? What exactly is it, and what are the different types you usually work with?
Sure. In Flutter, the simplest way to think about a widget is that it is the basic building block of the entire user interface. Almost everything you see on the screen is a widget. Whether it is a simple piece of text, a button, a layout element like a column, or even the padding and alignment around those elements, they are all widgets. I like to think of them as blueprints. They do not actually stay on the screen as permanent objects, but rather they tell Flutter how the UI should look and behave at any given moment. These widgets are nested inside one another to create what we call the widget tree. Regarding the types, the two primary ones I use are stateless widgets and stateful widgets. A stateless widget is used for parts of the user interface that are static. Once they are drawn on the screen, they do not change. For example, a label or an icon that just stays there. On the other hand, a stateful widget is used when the UI needs to change dynamically. This happens when there is user interaction or when data updates from a source. A stateful widget allows the widget to track its own internal state and redraw itself whenever that data changes.
That is a solid explanation. You mentioned that stateful widgets can redraw themselves. That leads me to a very common function used in those widgets. What exactly happens under the hood when you call setState inside a stateful widget?
When you call setState, you are essentially sending a signal to the Flutter framework saying, hey, the internal state of this widget has changed, and the user interface is now out of date. This function triggers a rebuild of the widget. More specifically, it marks the current element as dirty. This tells Flutter that it needs to schedule a call to the build method for that specific widget. Once the build method runs, Flutter compares the old widget tree with the new one. It does a diffing process to figure out exactly which parts of the screen actually changed, and then it updates only those specific parts. This is what makes Flutter so efficient, because it avoids repainting the entire screen if only a small piece of text or a color changed.
Exactly. Now, while we are talking about the widget tree, let us talk about build context. I see a lot of beginners struggle with this concept. What is the primary purpose of build context, and how does it differ from the actual instance of the widget itself?
I actually struggled with this at first too, but I think I have a good handle on it now. The main difference is that a widget instance is just a blueprint. It is a lightweight configuration object that tells Flutter what the UI should look like. These instances are created and destroyed very frequently as the app rebuilds. BuildContext, however, is not a blueprint. It is a reference to a widget's location within the overall widget tree. Because Flutter is a nested hierarchy, the framework needs a way to know where a specific widget is situated so it can look up information from its parents. For example, if a widget needs to find the current theme, the localization settings, or a state management provider, it uses the build context to look up the tree to find the nearest available service. So, while the widget instance describes what to build, the build context is the handle that allows the widget to communicate with the rest of the app.
That is a very clear distinction. Let us move on to some layout-specific questions. In my experience, developers often use container for everything. Could you explain the difference between a container and a sized box? When would you choose one over the other?
That is a great question. A container is like a Swiss Army knife. It is a very versatile widget that lets you do a lot of things in one place. You can add padding, margins, background colors, borders, and even rounded corners. Because it has so many capabilities, it is slightly more expensive for the app to render because it has to check all those different properties. A sized box, on the other hand, is much more focused. Its primary purpose is to set a fixed width or height for its child, or to simply create a gap of empty space between two other widgets. It does not have styling options like colors or borders. Because it is so simple, it is much more lightweight and efficient. So my rule of thumb is that if I only need to control the size of an element or add space, I use a sized box. If I need to add styling, decoration, or padding, then I reach for a container.
Good. Let us talk about lists, as almost every app has them. If you have a very long list of data, say 1,000 items, would you use a regular list view or a ListView.builder? Why?
I would definitely use a ListView.builder in that scenario. A regular list view creates all of its children at once when it is first initialized. If you have 1,000 items, it will try to render all of them immediately, which would consume a massive amount of memory and would likely cause the app to lag or even crash. The ListView.builder uses a lazy loading approach. It only creates the widgets that are actually visible on the screen at that moment. As the user scrolls, it destroys the items that leave the view and builds the new ones coming into view. This makes the app much more performant and memory efficient, because it only handles a handful of widgets regardless of whether the total list has 10 items or 10,000 items.
You mentioned performance. Beyond using a builder, how else would you optimize a long scrolling list to keep the frame rate smooth?
Aside from using the builder, there are a few other things I would do. First, I would make sure that I am not doing any heavy computations or API calls directly inside the build method. The build method should be as lean as possible. I would pre-process the data before passing it to the list. Second, I would use const widgets wherever possible. By marking widgets as constants, I can tell Flutter that these elements will never change, so it doesn't need to rebuild them every time the parent rebuilds. Also, if the list items have a consistent size, I would look into using a fixed extent or providing a fixed item height. This helps the scroll controller calculate the total length of the list and the scroll position more accurately without having to render every single element first to find out how tall they are.
That shows a good understanding of the rendering pipeline. Now let us shift gears to the Dart language itself. One of the core concepts in Flutter is immutability. Can you explain what immutability means in the context of Dart and Flutter, and why it is so important?
Immutability basically means that once an object is created, its state cannot be changed. In Dart, we implement this using the final keyword for variables that are set once, and the const keyword for constants that are known at compile time. In Flutter, this is a fundamental concept because the framework uses a declarative UI pattern. Instead of taking an existing widget and manually changing its color or text, Flutter destroys the old widget and creates a brand new one with the updated values. This might sound inefficient, but it is actually the opposite. Because widgets are immutable and lightweight, Flutter can quickly compare the old and new versions to see exactly what changed. This prevents a whole category of bugs, where a widget might end up in an unpredictable state, because someone changed a property deep inside it without the framework knowing.
Very well put. Now let us talk about asynchronous programming. In Dart, we have futures and we have isolates. Both are used for handling tasks that happen outside the main flow, but they are quite different. When would you use an isolate instead of a future?
This is a really interesting part of Dart. A future is used for asynchronous tasks that are non-blocking. These are usually tasks where the CPU is mostly idling, like waiting for a response from a network API or reading a file from disk. Even though we use await, the main event loop is still free to handle other things like animations, while the system waits for the data to come back. However, isolates are different. Dart is single-threaded, meaning it has one main event loop. If you have a task that requires heavy computation, like parsing a massive JSON file with thousands of entries or doing complex image processing, that task will block the main event loop. This results in the UI freezing, and the user sees those annoying jank frames. That is where isolates come in. An isolate is essentially a separate worker with its own memory heap and its own event loop. They do not share memory, which is great because it prevents race conditions. By moving heavy work to an isolate, you move that computation to a different processor core, keeping the main UI thread smooth and responsive.
You mentioned race conditions. Since you are a fresher, you might not have encountered this much in production, but theoretically, how do you prevent race conditions in Dart when dealing with concurrent data updates?
Right, because Dart is single-threaded, you don't get the same kind of memory-sharing race conditions you see in C++ or Java. But you can still have race conditions during asynchronous gaps. This happens when you have an await keyword. While the code is waiting for that future to complete, other asynchronous functions can run and potentially modify the same piece of data. To prevent this, I would use a synchronization mechanism. Since Dart doesn't have a built-in mutex in the core library, I would implement a lock or use a package that provides one. By wrapping the critical section of the code in a lock, I can ensure that only one asynchronous operation modifies that specific piece of data at a time. Other calls would have to wait in a queue until the current operation is finished, which ensures the data remains consistent.
I like that you thought about the asynchronous gap. Let us talk about the structure of a Flutter app. What is the purpose of the MaterialApp Widget?
The MaterialApp Widget is essentially the root of any application that follows Google's material design guidelines. It provides the overarching structure for the app. Its main job is to set up the theme, which includes the primary colors and fonts, and to handle localization for different languages. Most importantly, it provides the navigator, which is the tool we use to move between different screens. Without MaterialApp, we would have to manually set up a lot of the basic plumbing that almost every app needs.
Speaking of screens, how do you handle passing data from one screen to another?
For simple cases, the most common way is to pass data through the constructor of the widget being navigated to. For example, if I am on a list screen and the user clicks a specific item, I would pass the ID or the object of that item into the constructor of the detail screen widget. However, as the app grows, passing data through constructors can become a nightmare, especially if you have to pass the same data through 5 different layers of widgets. In those cases, I would use a state management solution. During my projects, I have experimented with Provider and Riverpod. These allow me to store data in a central place, and any widget in the app can simply request that data without it having to be passed down manually from the parent.
That is the correct approach for scaling. Now let's talk about the external world. How does Flutter handle platform-specific features, like accessing the camera or the GPS geolocation?
Since Flutter uses Dart and its own rendering engine, it cannot talk directly to the native Android or iOS APIs. To solve this, Flutter uses platform channels. This is essentially a messaging system. Flutter sends a message through a channel to the native side of the app. On Android, that message is caught by code written in Kotlin or Java, and on iOS, it is caught by Swift or Objective-C. The native code then executes the requested feature, like opening the camera, and sends the result back across the channel to the Dart side. In practice, most of us don't write the platform channel code ourselves for common features. We use plugins from pub/dev. Those plugins have already written the native code for us and wrapped it in a simple Dart function.
That leads us perfectly into package management. How does dependency management work in Flutter, and what is the significance of the pubspec YAML file?
Package management is handled by a tool called pub. It allows us to use libraries created by other developers, so we don't have to reinvent the wheel. The pubspec YAML file is the heart of the project configuration. It is a manifest where I list all the dependencies my app needs, the specific versions I want, and also where I define my assets, like images and custom fonts. When I run the Flutter pub get command, Dart reads the pubspec YAML file, downloads the libraries from the pub/dev repository, and then creates a pubspec lock file. The lock file is really important because it records the exact versions of every dependency that was installed. This ensures that if another developer clones my project, they get the exact same versions, which prevents the classic "it works on my machine" problem.
Very good. Let us move into some practical UI implementation. How do you handle user input in a Flutter widget?
To handle user input, I typically use the text field widget. To actually get the data out of that field, I use a text editing controller. This controller acts as a bridge. I can use it to read the current text, clear the field, or even set an initial value. If I need to react to every single keystroke, I use the onChanged property of the text field to trigger a function. But if I am building something like a registration form, I would wrap several text form fields inside a form widget. This gives me access to validation logic, so I can check if an email is formatted correctly or if a password is long enough before the user is allowed to submit the form.
Let us talk about code reuse. Dart has a feature called mixins. What are they, and how do they benefit the structure of a Flutter project?
Mixins are a way to reuse a set of behaviors across multiple classes without using traditional class inheritance. In Dart, a class can only inherit from one single superclass. This can be limiting if you want a class to have functionalities from different sources. Mixins allow you to plug in specific functionality into any class that needs it. For example, if I have several different controllers that all need a specific logging behavior or a specific validation logic, I can create a mixin for that behavior and then add it to those classes. Using the with keyword. This keeps the code clean because it prevents the base classes from becoming bloated with features that not every child class needs.
That is a great technical answer. Now I want to move into some troubleshooting. Imagine you are working on a project and an animation is not displaying correctly. What are the first 3 areas you would debug in your code?
First, I would check the animation controller and its listeners. I would make sure the controller is actually ticking and that the duration is set correctly. A common mistake is forgetting to call controller forward or forgetting to dispose of the controller, which can cause leaks or stop the animation from running. Second, I would examine the widget tree to see how the animation is being triggered. I would check if the animation is wrapped in an animated builder or a listenable. A very common issue is updating the animation value, but forgetting to trigger a rebuild of the specific widget being animated, so the value changes in the background, but the screen never updates. Third, I would verify the tween. I would check the start and end values to make sure they are different. If the start and end values are the same, or if the wrong type of tween is used, the animation might just jump abruptly or not move at all.
That is a very systematic way to debug. Now let us try a more advanced scenario. This is more of a design question. If you were asked to design a deep linking solution that handles path parameters, query parameters, and authentication guards, how would you approach that?
For a robust solution, I would definitely use GoRouter because it simplifies the Navigator 2 API, which can be quite complex. First, I would define a route map. For path parameters like a user ID in a profile page, I would use named parameters in the path like /user/user ID. GoRouter automatically parses these. For query parameters like a search term in search, Q equals Flutter, GoRouter provides them in a map that is easy to access. To handle the authentication guards, I would use the redirect property in the GoRouter configuration. I would create a function that checks the current authentication state from my auth service. If a user tries to access a protected route, like settings, and the auth service says they are not logged in, the redirect function would intercept that request and push them to the login screen. To make it a great user experience, I would save the intended destination. Once the user successfully logs in, the router could then redirect them back to the original page they were trying to reach. This separates the routing and security logic from the UI widgets, making the whole app more maintainable.
I'm impressed that you have looked into GoRouter and the redirect logic. Now, let us talk about networking. How do you typically make an API call in Flutter?
I usually use the HTTP package. The process starts by creating a function that returns a future, since network requests are asynchronous. I use a sync and a wait to make sure the app doesn't freeze while waiting for the server. Once the request is sent, I always check the status code. If it is 200, I know it was successful. Then I use the Dart convert package to decode the raw JSON string from the server. I prefer not to use the raw map throughout the app, so I usually map that JSON data into a custom Dart object, which I call a model. This makes the code much cleaner because I can use dot notation to access properties instead of using string keys in a map, which reduces the chance of typos.
That is the right way to handle data. Now, a final technical question. You have mentioned using state management like Provider or Riverpod. Why is this necessary? Why can't we just use setState everywhere?
While setState is great for local state, like a toggle switch or a text field in a single widget, it becomes problematic for global state. If I have user profile data that needs to be displayed on the home screen, the settings screen, and the checkout screen, using setState would mean I have to pass that data through every single widget. In between. This is called prop drilling, and it makes the code very hard to maintain. State management tools like Provider or Riverpod allow us to lift the state up. We can store the data in a central provider, and any widget, no matter where it is in the tree, can simply listen to that provider. When the data in the provider changes, only the widgets that are actually listening to that specific piece of data will rebuild. This is much more efficient than calling setState at the top of the app and rebuilding the entire widget tree.
That is a very comprehensive answer. We have covered a lot of ground today, from basic widgets to advanced routing and state management. Since you are a fresher, I want to ask, what is the biggest challenge you faced while learning Flutter, and how did you overcome it?
I think the biggest challenge for me was understanding the difference between the widget tree, the element tree, and the render object tree. At first, I thought there was only one tree. When I started reading about how Flutter actually works under the hood, it felt overwhelming. I kept wondering why there were 3 different versions of the same UI. To overcome this, I spent a lot of time reading the official documentation and watching some deep dive videos on the rendering pipeline. I started drawing the trees on paper to visualize how a widget is just a configuration, the element manages the lifecycle, and the render object handles the actual painting on the screen. Once that clicked, I felt much more confident in how to optimize my apps and why certain widgets behave the way they do. It taught me that it is important not just to know how to use a tool, but to understand how that tool works internally.
That's a great mindset to have. It shows you have the curiosity and the discipline to go beyond the surface level. Well, we are at the end of the interview. Do you have any questions for me about the team or the role?
Yes, I do. I would love to know what the typical workflow looks like for your Flutter developers. For example, do you use a specific architecture like B-low-C or clean architecture? And also, since I am starting my career, what are the expectations for a junior developer in your team during the first few months?
Those are great questions. We currently use a combination of B-low-C for our business logic and a modified version of clean architecture to keep our data and UI layers separate. As for expectations, we don't expect a junior to know everything on day one. We focus heavily on code quality and the ability to learn. In the first few months, you would be paired with a senior mentor, working on smaller bugs and feature enhancements, and participating in code reviews. We value developers who ask the right questions and are proactive about improving their skills.
That sounds like a fantastic environment. I really value mentorship, and I think that approach would help me grow quickly. Thank you so much for your time today.
You are very welcome. It was a pleasure speaking with you. We will be in touch soon regarding the next steps. Have a great day.
Thank you, you too. Goodbye.